Wonderful. All right, so it's time for our next speaker today. Now I know both of these companies too. We have Boston Server. We got Philip Cruz. He's the senior sales exec from Boston Server. And we have Rafael Montan from 2CRSI, and they always bring some really cool infrastructure stuff to talk about. So do me a favor, please welcome our next two speakers, Philip and Rafael. Come on up to the stage. Nice. You know what to do with the clicker. Good to have you here. Cheers.
Good to be here.
Go get them.
Good morning, everyone. I'm Rafael Montan. I'm the VP Head of Cloud Business at 2CRSI. I will be presenting the 2CRSI in Boston presentation here for our cloud solutions, together with my colleague Philip Cruz from Boston. I will take care of the 2CRSI part of the presentation. Giving the vision, strategy of our company, and also mention some of the cloud solutions that we're selling today. And then Philip will take over the part with more details and comparing different cooling solutions.
Yeah, cool. Thanks. Thank you. Appreciate it.
Oh, it's a build. So 2CRSI is a group of multiple entities. So we've got two which address different market segments, different customer needs. We've got two entities who do design and manufacturing of IT solutions. So 2CRSI is the group based in headquartered in France, in Strasbourg, not very far from here. We design high-performance service, innovative service, green service for many industries. Tranquil IT is another entity based in the UK in Manchester who designs very ruggedized, all-terrain IT, as they like to call it. Next to that, we've got a Boston entity, which is a value-add integrator and distributor, whose offering is focused a lot on super microservice, but not only that, they also say high-end AI solutions, such as the NVIDIA DGXs, HGXs, but also, for example, GraphCore. We've got two entities who have more of a vertical expertise and who provide expertise, consultancy, and turnkey IT solutions towards certain verticals. So we've got, for example, Buyers IT, who's got expertise for FSI segment, financial services segment, and who is selling, for example, HFT, high-frequency trading solutions into that market. They also have, for example, a Formula One team as a customer. Escape Technology in the group is focused on the needs of the media and entertainment industry, so selling high-performance workstations, but also clusters, server clusters, render farms into that industry. And the last entity is Green Computing, which is I would call it, premium co-location housing service targeted at HPC environments with premium options such as immersion cooling. We're a global company, as we say, global presence, but with local proximity in the key markets where we want to be present. So today we are approximately like 400 people, spread across 20 offices across the globe, across continents. We have 6 manufacturing facilities in the US and in Europe. The offices are not just Europe and North America, but also in APAC, Middle East, and Africa. We're a public company today. In 2018, Alain Wilmut, our CEO and founder, took the company public on Euronext. And last fiscal year, we did about 803 million euros of revenue. By the way, our fiscal year ends in February, so we're busy working on the numbers for the fiscal year which just ended. Our vision is to provide sustainable IT solutions for our planet. Since 2019, we already had developed solutions which are focused on reducing the power consumption of servers. And that was servers designed, optimized for direct liquid cooling or immersion cooling. We'll give you more details about that later. Today, in 2023, our focus of our R&D department is to develop solutions which can reuse the fatal heat coming from those servers. Okay, so that's not going to waste. And for 2025, we set ourselves a target of developing solutions not just to capture and reuse the heat from servers, but actually to be able to use them as an alternative source for electricity. So the graph on the left will be no surprise to any one of you. It shows you, let's say, the average data center PUE across multiple regions in the world. You can see that it varies wildly depending on the continent or the region. The US and Europe are among the best pupils in the class, so to speak. According to the latest statistics from Statista, worldwide average PUE in 2022 was 1.57, so there still remains a lot to be done to make data centers and servers more eco-friendly and more green. 2CSI has developed OCP, so Open Compute Solution, 21-inch servers, which address this issue. So for example, with our air-cooled solutions, we have servers which consume 23% less power compared to, let's say, traditional 19-inch servers. And this is not just us saying this. This is a testimonial from one of our customers who actually did the power measurements comparing 19-inch GPU servers with our solutions. And that were 4 GPU servers, so quite significant TDP per server. With DLC, with direct liquid cooling, we can capture up to 83% of the heat generated from those servers. With that, we can approach partial PUEs of 1.10. Partial PUEs because obviously PUE is a measurement of a data center, and we're talking here about the partial PUE just for the rack. In immersion, it gets even better. With immersion, we resell the tanks of multiple vendors. We approach, on average, a PUE or partial PUE of 1.04. But the challenge keeps getting bigger. I mean, you see on the left the graph with the trends for CPU and GPU TDPs. So you can see that it goes up quite steeply, and it's not going to stop there. You know that both Intel and AMD just launched the newest generation of Gen 5 servers, and now the power consumption of the high-end CPUs varies between 350 watts and 400 watts, and it looks like it's trending towards 500 watts for the next generation. For GPUs, it's even higher, so the current high-end data center accelerators from Intel, AMD, and NVIDIA consume between 500 and 700 watts today, and it's trending towards 1,000 watts for the next generation. So we definitely need to step up our efforts to keep ahead of this and to keep the ability to cool down servers, reuse the heat, and make them more efficient. One initiative I want to mention that we are part of is part of the European pilot, EU pilot, which is one of the key objectives for the European Union to march towards digital sovereignty. So we're part of this consortium of 20 private and public companies who each have a different role in achieving this. And the goal is to, by 2025 or 2026, to be able to build exascale computers, supercomputers, designed and built with technology designed in Europe. So 2CSI is part of that consortium. We're the one who will building server hardware for the accelerators, which will be built or based upon open architecture such as RISC-V. And of course, we will make those solutions immersion friendly. So we have solutions for the cloud, right? From the edge with Tranquil IT, as I mentioned, sorry, too quick. With very ruggedized IT, starting from very small form factor PCs, all the way up to, let's say, a 2U powerful server, which is completely passively cooled, which can be deployed in the harshest environments in the desert or elsewhere. And they also have microclusters with multiple mini PCs in them who can be deployed in those harsh environments. By the way, those solutions are, of course, water and dust resistant. We have, of course, already mentioned our air-cooled solutions. I mentioned our OCP racks, which we call Octopus racks. By the way, we don't do only OCP. We also do 19-inch standard stuff. So one of the solutions we're selling to one of our cloud customers is this solution with up to 96 nodes of very high frequency CPUs. So we're talking here about the mix of Intel Core, Intel Xeon E, or Ryzen CPUs, which don't have a lot of cores, but a very high frequency, and that is good for certain workloads to sell, let's say, simple, lightweight VMs. With our solution, you can cram more than 1,100 of these high-frequency cores into one rack. As already mentioned, it's 23% less power energy consumption compared to standard 19-inch rack servers. This is the equivalent of, let's say, 2,300 lightweight VMs or 480 VDI instances. We did some math for you to give you an idea of the ROI period for this hardware, just at the hardware level. If you're selling for 45 euros a month Linux VMs into the market, with these configuration, you would have a payback period of between 6 and 7 months. We also have DLC, direct liquid-cooled solutions. Here we can increase the density. Here we go for bigger, fatter CPUs. We can put 48 hot swap liquid-cooled blades or nodes into one rack. That's enough to increase the density to over 6,000 high-frequency CPU cores. Power consumption savings here are estimated to vary between 30 and 35%. Here we can put really high-end blades or CPUs in one node, so up to 128 cores in one node. Compared to air, we can increase density by a factor of 3x. If you look at the number of VDI instances, over 1,500 VDI instances could be deployed in one such rack. Again, we did the math for the ROI period. If you're selling a big Linux server, 64 cores into the market, let's say for 920 euros, then this would give you a payback period, ROI period of 7 months. I want to wrap up my part of the presentation with the last part for immersion solutions. So we have immersion solutions focused on HPC deployments, very dense, and also we have the screen computing premium, let's say, co-location service, which includes immersion options. Here again, we can increase density. We can have 106 big, powerful nodes in one tank. Here again, we're talking about high-frequency CPUs up to 3.5 gigahertz, more than 13,000 cores in one single tank. Compared to air, we increase density by a factor of 14x if you look at the number of VDI instances that you could deploy in this single tank. Again, we did the math for the ROI period, payback period. If you're selling a big, chunky Linux server, 128 cores, 2 times 64 cores for 1,650 euros per month in the market, then this would give you a payback of 6 months. Okay, so I encourage you all to come to our booth. Obviously, we've got people there who can provide you more details about these offerings. Okay. With that, I want to hand it over to my colleague, Philip.
Thanks much, Raphael. Thank you. Hi, everybody. Please, get applause for Raphael. Hi, everybody. I'm Philip, working as a senior sales for Boston's Munich office. It's a pleasure for me to be here, and even if the title of my presentation looks a little bit like the intro of a support group, it's actually about IT. And at the end, you will see it fits my topic anyways. As you all know, the modern IT environment delivers great benefits to humankind. If it's a simple thing like watching the movie of your choice at the time of your choice, or if it's something more complex like getting a whole body MRI checked for cancer cells within 20 seconds by an AI bot, whereas the best specialist in Germany would roughly need 2 hours for that. But it is also a matter of fact that the modern IT consumes a lot of electrical energy, and that can be a problem for humankind. As you see, the IEA evaluated up to 320 terawatt hours energy consumption just by data centers worldwide, excluding cryptocurrency mining, excluding consumer devices. Now you will say 320 terawatt hours, that's a number. But let me draw you a picture to the number. 320 terawatt hours theoretically means you can charge your Tesla Model S every day from 0 to 100% for the next 8.76 million years. You see, that's a lot. Including consumer devices, the energy consumption of IT overall is 10% or above, and it's still increasing. Despite these shocking numbers, I think we all agree we don't want to get rid of all the benefits IT is delivering to us. So the logical step must be to run our infrastructure as efficient as possible. Since most data centers today are still air-cooled, I want to start with an optimization for that based on a customer project of last year. The requirements were roughly 1,000 nodes. The CPU given by benchmark was roughly 280 watt on a dual socket, 1 terabyte of RAM, a little bit of NVMe, and an HDR network. So a classic HPC environment. Here you can see what the 19-inch world offers for such an approach. Either pizza boxes, so 1U, 1 node, or multi-node systems, like almost every vendor has them. Here you see two twin form factors is a 2U, 4 node. But on the next slide, you can see what we suggested to the customer. It's an OCP-based system, an Octarec 42SL, featuring 32 OpenU for IT, and a total power and cooling capability of 27 kilowatt, all air-cooled. The main difference to 19-inch servers is the centralized power supplies and the centralized fan infrastructure at the rear of the rack. In addition to that, our nodes had 2 closed-loop liquid cooling heat sinks to proper cool the 280-watt CPUs. I want to show you why we suggested this solution. These calculations just take into consideration the power consumption by the fans per node. You can see the 1U is using 8 fans to cool the system, each needing 24 watt, summing up to over 190 watt just fan power consumption. The first twin we saw is already very efficient, using just 166 watt fan per node to cool, but due to that, it is also limited to 200 watt CPUs. So it was not suitable for our case. The second twin we saw is using 2 of these fans in row to cool 1 node, but so it is summing up to over 130 watt of energy consumption just by the fans. Let me skip back to the last slide to show you our cooling infrastructure here. As you can see, 8 OpenU are cooled by 6 fans. It's EBM Papst fans, each using a 40 watt in peak. So the calculation is you need 0.75 of the big fans to cool 1 node. 40 watt peak gives us a 30 watt of power usage. The Dynatron closed loop liquid cooling needing 50 watt each, so 30 in total, and per node a total of 60 watt. On the right side, you see the spot price at the time when we had the project of the customer's data center for 1 kilowatt hour, 44 cents. And here you can see what your cluster will cost you in energy consumption just by the fans at a scale of 1,000 nodes within 1 year. And I think the numbers speak for themselves. Now one could say, okay, the OpEx side looks very, very good. But Philip, how much more do I have to pay initially to save afterwards? And the answer is simple, nothing. OCP setups are mainly less costly than 19-inch server, even on the CapEx side. But let us go to the next case. I want to compare 3 cooling types with the same IT setup underneath. We start with our actual installation in Munich. It's also an Octarec 42SL, but in this case, it's with direct contact liquid cooling for the CPUs. What you see here is a rack featuring 48 slots for half-width servers, featuring 48 kilowatt of total power and cooling capability, and enough space for switches and a CDU. Let us take a closer look at the power numbers. At the bottom, you see the setup we had in this project. So you see it's also an HPC setup, classically. The IT load, so everything consumed inside the server, the CPU, RAM, NVMe, and NICs, was 634 watt per node. The 15 fans we had to use at the rear of the rack were throttled to a 5 watt per piece, since the main heat was already removed by the liquid. And the CDU for the pumps needed roughly 500 watt. Brings us to a total of almost 26 kilowatt for the cluster in rack for a 40-node setup. But the tricky part is the data center cooling. Here we used values from one of our own data centers in France. They were giving us different PUEs. For air cooling, 1.5. For liquid cooling, 1.15, sorry. And for immersion cooling, 1.12. The PUE is the power usage effectiveness. So basically the calculation is you take the whole power consumption, including cooling, data center lighting, and everything, divided by just the IT load. So you can say the total costs divided by the usage. The closer your PUE gets to 1 or below, the more efficient your setup runs. As you can see here, I already mentioned the CPUs are liquid cooled, so with water blocks on it, all the rest is air cooled. The CPU TDP was roughly 70% of this setup. So you see 30% still air cooled is resulting 8 kilowatt. We have to use the air conditioning for. At a PUE of 1.5 means you need roughly 50% of the in-rack energy in AC usage. So you need another 4 kilowatt in cooling. Whereas the 18 kilowatt or 70% of cooling go by liquid, and liquid is to cool easier than air. So we have a PUE of 1.15. You need 15% roughly to cool down the water again. Gives us for 18 kilowatt of cool setup, gives us 3 kilowatt. In total, 7 kilowatt of DC cooling. Now let's compare this with an air-cooled setup. Same setup as mentioned. You see, the IT load obviously is the same since it's the same components. But you can also see here we need much more fan power to cool our setup. But even so, the 28 kilowatt in total in-rack power, it's just 2 kilowatts more than the DCLC setup. But anyways, at 44 cents per kilowatt hour, that's over 7,000 euro per year in more costs. But that's not the funny or tricky part. The tricky part is, again, the data center cooling. You remember, 1.5 PUE means I need 50% of the energy of the rack to cool it down with my air conditioning. Gives us 14 kilowatt to cool down the 28 kilowatt. And the last slide, or the last technique I want to show you, is immersed servers. Same setup again. What is immersion cooling for those who don't know? It means your servers are completely dipped in a dielectric liquid. The dielectric liquid removes the heat from all the components, uses natural convection to flow to the sides of the tank where heat exchangers cool down the dielectric liquid. So, the IT load is the same, but we need no fans and no pumps, just a little control board for monitoring. So this gives us the lowest in-rack power usage for immersion, but also here the tricky part is the data center cooling. You remember, for immersion it was even more efficient than for direct liquid cooling, since less pumps is involved. So you need 12% roughly of the in-rack power to cool down this setup. Gives us 3 kilowatt. Since there were a lot of numbers, let me give you an overview here. What you can see here, that the in-rack power consumption from cooling type to cooling type is not that different. But if you look at the data center cooling between air cooling and immersion cooling, there is a factor of roughly 4.6, and that heavily impacts our OPEX and our carbon emissions. But still, we can't say immersion cooling or OCP-based systems is the best solution for every customer and every case. One has to look at so many more facts to decide what's the best solution for him. Just to name a few, the existing environment. If you have no facility water, you can't put an immersion tank or a DCLC rack. Or a potential problem with liquid cooling. If a leakage occurs in your cooling system, the whole IT setup can break down. Or another thing, the geographical position. If your data center is in Iceland, probably air cooling or free cooling is the best solution for you. But one thing I can prompt for sure, if you come to us for your next solution, we will consult you to the best. Thank you very much for your attendance. Hope to see you at our booth.
Thank you both so much. Quick question on like the different cooling types that you've presented today. With the European pilot that you had mentioned earlier, do you see changes within the technology? Have you implemented those changes since being a part of those pilots, or has that not had an effect? Have you all had the vision for these different types of cooling systems since the get-go?
Well, the outset is still to, as I mentioned, to go towards immersion-friendly solutions because we feel it's the most cost-efficient way of cooling down systems, and also it has a positive impact on, let's say, the longevity of the components in the liquid. It gives some challenges maybe, or from a maintenance point of view, but we know how to address this with the partnerships we have with immersion tank vendors. I think the key goal for us is to make sure that we have this sovereign technology developed, designed, and manufactured in Europe as much as possible.
Wonderful. Thank you both so much for the time.
Thank you very much. Bye.
Thank you.
Thank you.